So now that we know more about minerals and how to identify them and rocks and how they're formed, we're going to go ahead and practice some of our science skills. And I'd like you to go out. It can be in your backyard, or maybe you choose a natural area that you want to hike to. It doesn't really matter. Whatever you want to do, just grab 2 rocks from somewhere. And you're going to try to identify these rocks. I'm going to introduce you to a series of different tools and tests that we can use in order to identify rocks. My hope with this lab is that you get some hands-on experience with some tests that we can use to identify rocks, but also that you might find it enjoyable, and this might spark a hobby of rock hounding or just learning more about rocks. And so that's really the purpose of this lab, is to introduce you more to the scientific process, to engage in it, to learn some tools, and then hopefully find some enjoyment in identifying rocks. So the first thing you're going to do is just take a picture of your rock and upload them into the chart of your lab. And then the second thing is that you're going to find some kind of AI program or rock identification app. You can find a lot of them for free or do a 7-day trial. I have a link that takes you to 5 free apps. You can use Google Lens, just whatever is convenient for you. Find out what the app says that your rocks are and go ahead and put those in the chart. Number 2 is the dichotomous key. So a dichotomous key presents 2 questions. They're often yes or no questions, and based on what your answer is, it tells you which question to go to next. And it's kind of like that choose your own adventure book where you figure out what describes your rock, tells you where to go, you keep following it, and then at the end, it's going to tell you what your rock is. Now, these may not be accurate, but we're just being introduced to the processes and to these tools. And it's helpful to have different tools to identify your rock so that we get a more accurate and confident result. Okay, so the third thing, or that's number 4 on your lab, is that we're going to perform some physical and chemical properties tests. Okay, so I'm going to go ahead and walk you through how to do some of these tests. I'd like you to try at least 4 of them. You may not have all of the materials at home, but a lot of these things you can get either at a dollar store or hardware store or things that you just have around the house. And just try to do at least 4 of these or more if you have the materials and the time. All right, so the first test is luster. You're just going to look at your rock and determine if it's metallic, subetallic, or non-metallic. So a metallic rock will look very shiny. It has the look of like polished metal. It's going to reflect light, and it's going to just look like very polished metal. Okay, so y'all kind of know what that looks like. Then it might look metallic, but more dull, or looks like it has holes in it, and it's just not a polished metal, but it might be metallic. So that would be a submetallic. And then we also have non-metallic. So all of these are non-metallic. They're kind of glassy. They look like earth, or they're powdery. Some of them look waxy. And so basically you're going to follow the chart and the descriptions in this section, determine what your rock looks like. And if it's non-metallic, it has further descriptions that you're going to choose from. All right, so the next test is transparency. It's pretty straightforward. You're just going to look at your rock and see how light goes through it. So if it's transparent, the light is going to enter through it without being distorted and go through the other side. So you can actually see all the way through it pretty clearly. These are examples of transparent. You could almost read something that's on the other side. Something that's translucent, the light is going to go through it, but it's going to be distorted and look like frosted glass. The third option is opaque, so light does not shine through it, and you won't be able to see through the other side. All right, the next test is the hardness test. We're going to use the Mohs hardness scale for this, and I'll show you some examples. So the first thing you can test it with is your fingernail. This is a piece of talc, and talc is a very soft rock. We can test it with our fingernail just by scratching it like this, and you can see that it is definitely softer than my fingernail. So it would be probably a 1 or 2 on the scale, and you have the scale on your lab sheet. The next thing that you can test it with is a copper penny. So we're going to go ahead and test calcite with a copper penny. So here's calcite. And you basically just want to scratch the penny on it, and you can see that the penny does scratch. So a copper penny is around a 3.5, so we know that it is softer than a copper penny. Calcite would be lower than a 3.5, but the fingernail does not scratch it, and so it is more than a 2.5. So basically you're just using the different things to test to see where it falls in the hardness scale. Okay, the next thing that you're going to use is a glass. The glass is something that you could get maybe at a dollar store, like in a frame, but you definitely want to be careful not to cut yourself. This is fluorite, and if we tried to scratch the glass with fluorite, you could see that it does not scratch the glass. Or it's very hard to scratch it, and so we know that fluorite is not as hard as the glass plate, which is about 5.5 on the Mohs scale. The next thing you can try is the steel nail. So we'll look at quartz here. So if we tested quartz on the glass plate, you can see that it very easily scratches the glass plate. So we know that it is more than a 5.5 on the scale. But if we use a nail to test it, then we'll see that the nail does not scratch quartz. So quartz is not as hard as the steel nail, or it's kind of about the same. So that would be about a 7 on the Mohs hardness scale. And so whatever your rock wherever your rock falls along that scale, you're going to go ahead and estimate where it is between these objects on the hardness scale. The next test is the streak test. So this is helpful because each rock has a characteristic streak, a color, and also you can tell how hard it is to streak a plate as well. So you would use an unglazed porcelain tile, and so again, this might be something you want to get, or maybe you just have around the house. If you have that, that would be great. And what you basically do is you use the rock and streak it across the porcelain tile. This is pyrite, so it looks very shiny and gold, but you can see that the streak is kind of a gray color here. This is really helpful for identifying rocks because they each, again, have their own characteristic streak. This is graphite, so this is what we use in pencils, and as you can see, graphite very easily streaks off on the white plate, and it is a dark gray color. So I'll show some other examples. This is galena. It looks very similar, but it has a lighter streak color than graphite. This doesn't have a streak on a white porcelain plate. So if it doesn't, you could test it on a black one as well. So let's see if it leaves a streak on the black tile. And it does. It leaves a white streak. And so you can use white or black depending on which one it leaves a color. So you would say it has a white streak on a black plate. Here's a red rock, and if we streak it on the black plate, we can see that it leaves a red streak, and also on the white plate, so it has a red streak. So if it doesn't streak on either of the plates, you would just record no streak. Okay, this test is going to be cleavage. Basically, you're looking at how it forms at different angles and which planes. So we're going to just kind of describe it as either perfect cleavage, which means that it cleaves without leaving any rough surfaces. A good example is calcite here. And you can see it forms these nice flat surfaces. Good cleavage also leaves smooth surfaces, but it kind of leaves a minor residual rough surface. So halite could be an example of that in some places. Sometimes different samples of quartz, but just depending on your rock, you can just decide the best description. All the way down to fracture, which means that it does not exhibit cleavage, but it's broken in irregular, fractured, and rough ways. So obsidian could be an example of that. And also this olivine, sometimes it's really hard to tell because you have to look very closely. So if you have a magnifying glass, you might see small crystals in there and how it is cleaved or fractured. So just do your best to look at the descriptions and then try to match your rock with whatever it fits best. So the other thing you're going to look for in cleavage is the direction. So in your lab, it's going to give you examples. Cleavage in one direction would look like this. It might come off in sheets, and you can kind of see that in your rock. It might not be in these thin sheets, but you can see that they might form these layers like this. So this is muscovite. It's a good example of cleavage in one direction. Cleavage in two direction would just be in two planes. Cleavage in three directions, an example of that is halite, where we have 3 planes, 1, 2, and 3. And then calcite, we really have 2 directions here because we have it at an angle. So you can look at the example in your lab manual. Try to match up which one is best according to your rock. And that is if it has a characteristic direction. If it doesn't, then you won't need to worry about that. All right, so after you have determined cleavage and fracture and best described your rock according to the descriptions, the next one you can look at is if it is magnetic. So here's an example of magnetite, and basically all you need to do is get a magnet and put it up to the rock and see if you feel kind of a magnetic pull. So magnetite is magnetic and it will hold a magnet to it. Other rocks are not as strong, but if you feel any kind of magnetic pull at all, then you could say that it is magnetic. All right, the acid test, you're going to use vinegar for this, and basically you're looking for a reaction. Some rocks have a more basic mineral in it, like calcium carbonate, and so it will react with an acid. And I'll use hydrochloric acid here just so you can kind of see what the reaction might look like, but you just use vinegar, which is an acid that most people have in their home. So here is calcite, and you're basically just going to put a few drops on it, and you can see that bubbles are forming on the calcite. That's due to the calcium carbonate in it. Limestone is another example of a basic rock. So there's other reasons why your rock would react with the acid. Here is halite. We're going to go ahead and drop acid on there, and you can see that it is not reacting. So it's basically you're looking for bubbles or no bubbles, and go ahead and record that in your sheet. The next test you could do is fluorescence. So if you have access to a black light or UV light, basically you'll just want to go into a dark place and shine the UV light over it and see if your rock will fluoresce at a different color or kind of look like it's glowing. Okay, so the last test is specific gravity. So I'm not going to demonstrate it here, but there's a really great video that shows exactly how to do this. You could possibly do this with a kitchen scale, a cup of water, and then either a string or a paper clip that you can suspend the rock in. And the specific gravity is basically the ratio of the density of your rock to the density of water. And the way you can do it is just by figuring out the weight of the cup of water and then the weight that results when you suspend the rock in the water. All right, so now that you have performed at least 4 of those tests, you've used your app to come up with an answer of what your rock might be, you follow the dichotomous key, and now what you're going to do is follow the link to the MindNat searchable database. You're going to put in what you think your rock is based on the information you have, and any of the tests and information that you have already, put it into that database, and it's going to produce some options of rocks, and that it will also give you a percentage of match. So you're going to go ahead and record that. Finally, you're going to go ahead and draw your conclusion. What do you think your rock is? So on the very last section of your lab, you're going to write a conclusion. You want to make a claim about what you think your rock is based on the evidence that you have. State your evidence, and then you want to give your reasoning, linking your claim to the evidence and why you think the evidence supports your claim about what the rock is. Then you want to say how confident you are that you know what the rock is based on the evidence that you've gathered. And then finally, what further tests or questions might you ask in order to be more confident in the identification of your rock? And this is going to give you practice on how the scientific process is done. Remember, we don't usually prove things once and for all in science. We just see if the evidence supports our hypothesis, and then we can usually through statistics determine whether our evidence supports it and how confident we can be in the conclusion that we've made. So I hope you have fun with this rock identification lab, and we'll see you later.